So I'm trying to make valid triangles and it doesn't work. And apparently, I was trying to already delaminate them, swap them, but apparently we get some invalid triangles here. Like this is not valid. This thing. So now maybe what I'll try to do is say. So first of all, maybe not add the edges here. So I feel like our splitting, and now it worked magically. So like we have a triangle for everything. Of course, some of those triangles are extremely big, since we do not swap them yet. Not sure why edges particularly. Maybe this is duplicated. Yeah, if this is duplicated, that would explain a lot. Well, it prevents duplicates a few times. Way too many times, though. I don't know what's wrong here. Thing that I'll do here is say if game state uplift. So if this is not set, we'll just not bother. This is not a valid map. Sometimes it tries to make an F mesh for an invalid map. It's really annoying. Duplicate prevented. It says it 8 times run? Really? It should be 4? Or are we generating this 4 times? That would be crap. Yeah, we are. XD. This does seem correct. Oh, this is junk, by the way. Should fix that. Didn't really change anything. Wait, one. Oh. Um. Uh. No issues here. Once we have both edges and the middle points, it seems like it just cactus for some reason. Oh yeah, this like weird triangle here. Can't say what it is. But we get turbo cactus here. This doesn't even connect to anything. I think triangle contains is broken, honestly. If I will offset those, they will just work. Or rather, I should only offset them in one axis. I think it will just work now. I don't think points on the edge of the triangle are... I don't think they work correctly. Yeah. That is exactly it. And that's a big problem. Contains, right? Ah. Let's see, tonic. I think this is what needs to happen. Basically. Yeah. This is correct. And now what I need to say is tolerance, like this. So remove all that. Tolerance will set to this. And we'll say that. Okay. I think that now will allow us to just have them perfectly lined up, and it should still work. No, point without triangle, it's fucked again. I don't get it. Honestly. How this is with what? Or whatever. I think what I will say here is actually we copy this. Right, and I will now have it for later if I need it. This seems accurate right now. Yeah, also I'd rather have it like that. Yeah, okay, let's try to Delayan. Okay, swap triangles when they're considered invalid ones. Yeah, I don't think those ones would be Delaney. I mean, we only do one pass, we don't do it recursively yet. But we already have this error, which is not good. So right now, we should only say this, but what I will do... Found inverted edge. Okay, that doesn't happen. Now adding and duplicate prevented can be removed. Like, at least I don't see fuck triangles here. There's definitely a problem when we lose or some... Oh, I know what it is, actually. What do we need to do? Yeah, this is gonna be painful. Yeah, because we don't update the block pointer. That was foolish of me, but it said adjacent. CPP set O, and we'll say This is actually A, sorry. And this is 0, 0, 1, 2. Actually, I feel like I'll do something else. I will do index as the second thing. So that only makes sense. Like it lines up it just ends up being way more readable. Is my argument for it. Okay, and now for A, we just do A copy adjacent, B adjacent, and B. And technically, the adjacency of B wouldn't be very much necessary, but okay. What I will do right now is actually reorganize this a bit. So I'll do this instead. Because set adjacent actually needs to use the points to be correct for the edge search. And I think when we now run this, it should be correct. I hope. Oh, no issues. Okay, now let's try recursiveness. If it works, we're very happy. Wait, no errors. And it is Delonide. Holy fuck. It is Delonide. So now we can remove the super triangle, I guess. Although I will first test on an actual dataset because this is like a temporary one. No, not this. This I can remove. This I can also remove. This point here should be removed anyways. Okay, and now let's try to generate edges. I think we're done actually. Seems correct on all fronts. We have the delineation. Holy fuck. It works. It seems like it almost always works. No, actually. We need constraints to. Holy fuck. This works. This looks so epic. And now what we can do is remove the super triangle. Dude, it works. Holy fuck. Well, actually, I haven't read on constraint yet, so. Again, it sucks. 90 minutes in, I don't know what to do anymore because I just fucking finished it. Of course. Dude. Dude. This is a screenshot. Dude. No way. This is hype. This is fucking hype. Dude, no way. And one thing that makes me uncomfortable with this is that I don't understand the math behind the swapping check. And not really. I mean, I know that it's checking for the circumcircle, but I don't know why the sin AB less than 0 guarantees then. Not sure, but holy fuck. Okay, so now what we need is like an add constraints function. So we'll say add constraints nav mesh. And we'll use the main. This is all I need for now. Okay. So we need a static void add constraint nav mesh set v2 start v2 end, right? That's all we need. And now this add constraints just says iterate over our set of things of edges. And we add the constraint one by one. And count. See, edge equals nav mesh edges. And yet again, this can just be a v2 instead of nodes points. Okay. And now instead of doing nodes like this, I would just say we add those because we need to. Then we also do this. Okay. Points. Okay. And now one thing, points. One thing for performance will actually be the triangle search, but that doesn't need to be now. More important is that the algorithm works. Also, when I finish generating the nav mesh, I will still have to A-star it. And the tricky part about it is that you have to A-star it with, or rather A-star, not Navstar. That's Navstar is new algorithm. But the problem is when you have like dude, I'm so hyped for this. Anyways, but when you have something like this, right? You have like a unit here. Let me even see this. You have a unit here, and it's, let's say, this big. And you actually want to pick like you want to reduce this to like this, and you probably pick the midpoint here, or rather, I mean by default I think we would do midpoints, right? And by midpoint I just mean the closest point to the previous point. So in this case, this probably is here. And I don't fucking know. Say we wanted to buff here, right? That's how we would do it, but now sometimes you'd want to slide it to the right and sometimes to the left. So maybe what we do is first we generate all the midpoints and then we slide closest point to the edge, right? So this would be like this. But then it would actually be this and it would be this here. So I don't know if that's how it should work. Probably what it should do is pick closest to the edge end. Go here and then closest here, then closest. I don't know. Because this is yeah, I don't fucking know how to funnel this. And let's do constraints first. It's more important. And to do that, I think I'll need to read this paper. Not this one, actually. This one. And let's see. See what it says. Yeah, this I don't really get done without some visualization, I don't think. I'm not very mathy. I tend to struggle with chiseling the Fury here. But uh yeah, I don't know how to do this either. I would not. And there are actually two. There's this one and the first one. The first one is without constraints. And the first one I think is a bit simpler to read. And this one, because this one seems to like skip the first like phase of generation a bit, because at least like I found it to be less readable like here, where it like defines the variables in line or whatever. So I would recommend first reading actually the second one I posted is the first one to read probably, and then the first one I posted and the first one I posted is with constraints, so it's more advanced. And there was still like yet another one for like pathfinding over convex polygons. But I don't have the link in hand, so. I can show you what it looks like. And yeah, I'm still figuring it out. This is what it generated. You can see that edges, like terrain edges, will sometimes, like here for example, this should be a line between this vertex and this vertex, but there isn't. And that's why we need to do constraints. So basically the idea is we would remove those two edges and then we would recreate the Delaunay triangles. But I have not read the algorithm for that yet. I didn't expect it I would be finished with the normal Delaunay today, honestly. It was pretty rough yesterday, but now I was able to really quickly fix it. And yeah, this would be enough mesh where you would start the triangles, and it would be really fucking great. And since we don't guarantee constrained edges, I also cannot add collision data correctly, and it would be nice to have that. Yes, it will be used for pathfinding. Right now we have like rough. It's actually Theta Star, but it's over a grid, and it's really. I mean, it's better than it used to be because they like sort of follow like straight up paths, but sometimes really degenerate. And with the Delaunay tab, it will be fucking great, honestly. But it's I don't know. It's very for my standard. It's pretty complicated. I don't usually deal with. Like this is the most map I ever dealt with in terms of making this engine, I think. So it's not particularly simple, but I guess now that I did it, it feels simpler than it was to than it used to. It's just like I still don't really understand the equation. Like I know the circle thing or whatever, but yeah, I think it looks pretty good. If you skipped to the beginning of the stream, it was actually very fucking awful. And there were like edges which would like not even be like not feel like they are actually triangles or whatever. Now it just works. Yeah, because like when I was swapping them for the Delaunay triangulation. Also, wouldn't this be better if it was like that? I guess it doesn't matter. Both triangulations would be milder, would they? Because if we swapped here, and then this one, no, actually they would be the same, I think. Like sometimes it feels like it could do something better, honestly. Like here, is this really the best we could get? I guess so, because otherwise it would just connect here, which would be the same effect. Yeah, so maybe it's all good now. The way this works is very weird because what it does, it actually operates on edges. And right now my primitive is a triangle and I don't have edges as themselves. Conceptually. So that's what the original algorithm implied, but here, I don't know. I feel like I will actually do something else though, because I think I will do triangle marching for performance right now because that I know how to do. So this is this. Where instead of like iterating on them randomly, it would just pick the next closer and eventually find a triangle. So now this is in. No, this is not in. This is in, right? It's trying to find a triangle. Here I think I'll just say static void triangle, nav triangle, find containing triangle, nav mesh. And this would be the position, right? Oh yeah, it's, I don't know why I took the void. Now the problem with this algorithm is that if there isn't a triangle containing the point, we probably fucked. Basically what we would pick here is the last triangle, right? Obviously, if there are no triangles, that would be a crash. So we can just return 0, I guess. Return triangle. Triangle. If triangle contains, right? If this triangle contains the position, it's when we return the triangle. Otherwise, we say triangle to be one of the adjacent ones. So we'll say I0, I3, I like this. Nav triangle, adjacent, or order maybe. Triangle, adjacent, I. If no order, that's when we continue. Right. And if there is another, that's when we say Now all we need is a normal, and to get the normal. I think I have that somewhere. I have it here. This would be our edge. Now what we want is to normalize it, which is a bit expensive. Of course. And now what we say is dot product. Of the normal and position. Does that make sense? I think so. Actually, the triangle center is the current triangle, like this. Best triangle is 0. I guess maybe best dot should also be 0. That way, if we reach the... If we reach a border with no triangle, we would just return. And as also you don't want to normalize, I think. And with this one, that's actually easy because we can start here, pause. Or no, actually no, this has to be here. Pause diff equals this. Okay, I'm doing a line. And actually, let's name this triangle containing, like this, find triangle containing. And now here is what we would say is, you know, that constrains it correctly. Here, this would be it. Nav mesh, pause. See how that works, and let's hope that's faster. Doesn't work. In one. Oh, of course. This break is now not sensible. And actually, this can be now simplified to saying this, right? Else. Could immediately set it to inactive too. And now we are stuck. Might be that the normals are inverted here. This one worked. What the fuck? Mm. Hmm. Yeah, I don't know. That seems to be broken. Well, this might still be a problem since we may have a fucking circle. That's weird. How would that even happen? They like. What is the fucking point? How many triangles do we have? We have 5 triangles. Yeah, how does this work exactly? Actually, I think this is simple, right? So we don't need to normalize here. And all we must say is that if it's greater than 0, Yeah, let's draw this. So basically we have a rectangle here and here and here, right? This point is here, so we split it like this, and we know this is here, so we choose this one, and then we split it like this, we go here, and we choose this one. It's very fucking simple. But somehow that doesn't work. Maybe I was doing it wrong by using the triangle center, since that's technically wrong. Oh, at least might be. Let's see if release does it faster. Yeah, it works now. Epic. Technically, it should be faster. I don't know if it is right now. Probably not. Yeah. I think this has to be it for today, though, because I need to read up on constrained edges, constrained Delany. Read up, think about it, watch about it, and see. As I have to formulate a plan of action for this, I'm not exactly sure. Like, I don't want to write code, like aimless code. It never ends well. Never does anything useful, really. And once we have that, it will be. So I assume like 2 or 3 days from now we could have pathfinding. Because if I do constraint tomorrow or after tomorrow, and then I do pathfinding the next day or the second next day, then maybe we are just done. Maybe it just works. And that would be fucking great because we would finally have precise and fast pathfinding. I mean, one day would also want to support removing and adding constraints dynamically, basically. I mean, like, if I want this cliff to disappear, I don't want to, like, select every vertex from here, remove those triangles, and retriangulate. And also, like, adding stuff is already possible. Although maybe not, because... I mean, yeah, it is. It is possible. I will have to restructure the program for it a bit, but... Yeah, this is really fucking epic. Then we have Dala 9 right now. Will be a big step up when we actually have it. Yeah. Now this is it for today.